Hello everyone, welcome back to Let's Code with Shiva. In today's video, we're going to be looking at how to implement a graph data structure in Python. A graph, as we know, is a non-linear data structure that consists of points called nodes or vertices that are connected with lines that are called edges. We can think of it as a map of cities that are connected by roads. This visual representation is very easy, but how do we represent this in code? For that, we have this concept called adjacency list. Like the name suggests, an adjacency list basically helps us track for each vertex what are the given adjacent nodes. An adjacent node basically means a neighbor to which a vertex has a direct edge with. It is implemented as a hash table, with key being the vertex and the value being the list of the neighboring nodes. In this example, A is connected to B and C. So this is how the adjacency list looks. B is connected to A and C. C is connected to A, B and D. This is how the list looks. And D is connected only to C. So now that we've gotten the hang of it, let's start defining the graph. Since graph is an ADT, an abstract data type, we'll be able to represent it using a class. So class graph, let's define the constructor. Now as we know, we are using the adjacency list, right? And it's a hash table. Now we can use a dictionary in Python for this. So let's say self.graph equals an empty dictionary. Now we also know that a graph can be directed or undirected. So here, let's add another parameter called directed to represent this. And let's set it to false because right now we're dealing with an undirected graph. Now let's define a function to add a vertex. This function has a parameter called vertex, which will contain the value of the node that we are going to create. If the vertex is not already present in our graph, we'll add the key to the hash table with empty list of neighboring nodes. Now let's try to see if we can add edges. So for adding edges here, we'll have a source node and we'll have a destination node. Before we update the adjacency list, we also need to ensure that both the source and the destination vertices are already there. Right? So let's use the add vertex function that we already created. Don't worry, it will only add the vertex if it's not already there. If it's already there, then it does not do anything. Now that we've confirmed that both our source and destination nodes are a part of self.graph, it is time for us to add the information about the edge onto self.graph. For this, we need to update the adjacency list of the key source with the value destination. So the syntax for this is self.graph of source.append destination. Now with this, we've added the edge that goes from source to destination. This is fine for a directed graph. But if our graph is an undirected graph, then it means that the edge from destination to source also has to be added. Let's add a check to see if the graph is undirected, and if so, we'll add the reverse node as well. Now let's start populating the graph with vertices and edges. Since our graph class is already created, let's create an object for this. For this graph, let's start adding the edges. We can do this with the addEdge function that we've created. So g.addEdge, we can give the source and destination. So for this, I'm adding 4 edges, A to B, A to C, B to C, and C to D. Note that addEdge function already contains the addVertex function within it, so we don't have to explicitly add the vertices here. Now let's display the graph. So displaying is pretty straightforward for us because we've used a dictionary to depict the hash table. So we'll just iterate over each of the keys in the dictionary and print the values. And let's also use an F here so that it gets formatted correctly. Now let's run the program to see what the adjacency list looks like. Awesome, this is exactly what we've expected. So in this technique, we've seen how to represent the graph as an adjacency list. There are also other representation methods like edge list or an adjacency matrix as well. You can use this as a template and modify the code here in such a way that each of the representations work. So hope you liked this video. I'll be posting next about the graph traversal methods, so stay tuned. Thanks a lot for watching. Do subscribe, like and share.